kids. Wow, it's a lot of gray there. All right, anyway. Hi, kids. I'm going to do one more little instructional video about systems and about conservation of energy. So let's first talk about, like, systems. What are we talking about with the system? So, because this is really important when we talk about conservation of energy, you have to be able to identify what the system is. What is the problem talking about? So a lot of times if they say, for example, hey, your system is this random object, okay? And it says it doesn't include the Earth. So if the system is just that object, what kind of energy can that object have? Well, that object can only be moving or not moving, so it can only have kinetic energy. So if you ever have something like this, where it's like, hey, your system is a random object. So here is a random object. It's a ball. And this ball is going to fall straight down. And so it's going to go from point A to point B. Well, just like you guys are taught to do, if you say, well, if my system is only the ball, well, that means the ball can only have kinetic energy because, potential energy depends on something else to interact with it. So in that case, well, if I go from A to B and my system is only the ball, well, at this point, I have no energy. And at this point, I have kinetic energy. Well, wait a second. I can't go from no energy to kinetic energy. Oh, that means work had to be done on my system. What did that work? Oh, that would be the force of gravity did the work. In fact, if you're to do the force of gravity times the distance that you apply it, you get mgh. That's later on we're going to get that. Okay, but does that make sense? If your system, guys, is only the object, you can only have kinetic energy. All right? So there's that. All right. So now let's say, because most of the time you're going to have something like this, so now let's say that you have your system is the Earth plus the object. So if this system is, if it says something like, hey, your Earth object system, blah, 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 and you wanted to do this, well, in that case, if I do that same problem where I have a ball falling down, and I'm going to go from A to B, well, now, if my system includes the Earth, now I have gravitational potential energy, because I have gravity. So gravity is going to be part of my system. So if I do this, hey, if I go from A to B, now I have potential energy, and then I go to kinetic energy, and hey, guess what? As long as there's no air resistance and everything else, nothing else is going to do outside, is going to do work on it, so I get this, okay? But it's like, and you might think, well, geez, that looks, it's very similar, but it's how you think about it, okay? So identify your system. If, let's say that I have something like this, or I have a block that is sliding down, okay? So my block is going to start from rest, it's going to slide down an incline. This incline has friction, and then later on, maybe there's, I don't know, we'll say that this part is frictionless, okay, just to, if I label some stuff, if I say, hey, I want to go from A to B to C or whatever, if my system is just the Earth slash box system, and let's say I want to go from the beginning to the end. Well, if I go from the beginning to the end, well, if I have the Earth in the box, that means I have potential energy I can use. I have kinetic energy that I can, have available to me. So at the start, if I'm starting from rest, this would be potential energy. And then later on, this would be kinetic energy. But here's the deal, okay? In this case, this potential wouldn't equal this kinetic. Why not? Because there's some friction, which is from this surface, which means I have some outside force doing work on my system. Friction is a non-conservative force, so that means I'm going to lose some energy, so that, hey, you know what, you're going to have, it would look like this, and you would solve. Just keep in mind, this number, when you plug it in, would have to be negative. Why? Because it's taking energy out of your system. Yeah, but let's see, what else? So let's say we did a problem where it was like this. You had the Earth surface, box system. So now, hey, it's all included. Well, in that case, Earth, surface means that I can have friction as part of my system, which means now I can include heat energy. So if I was to do this and go from A to C again, what do I have at the start? Well, I have potential energy. What do I have at the end? If it's moving, I have kinetic energy. And then if there's definitely going to be some heat that's produced, so I'd have heat or thermal energy. And then there isn't any outside force. So it'd be like, hey, this doesn't equal this. Well, why not? Because there's some heat that was added. So just keep in mind, guys, this idea of you got to identify your system. But otherwise, as far as doing conservation of energy, it's like we've been doing. If you need specific help on doing conservation energy problems, watch one of the other videos. Bye, kids.